Hello, this is Rick from MathX, and today we'll be solving the number 28 from the 2018 Math Kangaroo for 5th-6th grade. Now, this is the number 28 on the Math Kangaroo, but this problem kind of deceives you because even though it's on a competition called Math Kangaroo, to solve this problem, there's like nearly no math required. To solve this problem, you just have to think creatively outside the box. Using the information that it gives you, you have to be able to make up certain deductions and then use said deductions to solve the problem. So that's what I'll be showing you today. How to make up these thoughts on the fly while just reading the problem, and how to use that to solve this number 28. So without further ado, let's just get into the problem. 14 people are seated at a round table. Each person is either a liar or tells the truth. Everybody says both my neighbors are liars. What is the maximum number of liars at the table? So the problem gives us certain clues in this case. It tells us that there are 14 people at this table, that everyone's either a liar or tells the truth. There's no in-betweens. Along with that, everyone's saying that both my neighbors are liars. And using this, we want to find out the total number of liars at the table. So let's think about what this means. Let's say, since everyone's saying that both my neighbors are liars, then we know that there are at least some liars amongst them people, and we're trying to maximize that. So let's think about it. If a liar is saying that both my neighbors are lying, how could he be lying about it? Well, if a liar says that both my neighbors are lying, there are two things that could happen. The first case is none of his neighbors are liars, because he's a liar. He's not telling the truth. So if he says that both my neighbors are liars, well, that's the complete opposite of what's happening if both his neighbors are people telling the truth. So then we can see that's one case of him lying, if both of the people he's sitting next to are telling the truth. Here I'm going to write TT for truth teller. The second case is if one is the truth teller and one is a liar. If he says both my neighbors are liars, that's not true because one of them can tell the truth. So once again, this is a lie, something a liar would say. So one truth teller and one liar. So we see that every liar who says both my neighbors are liar could either be saying one of two things. Both of the people sitting next to him are truth tellers, or one of the persons sitting next to him is a truth teller and the other is a liar. Now we want to maximize the number of liars. So having both people as truth teller, that won't do that. It'll not maximize the number of truth tellers. But if we have next to each liar one other liar, then that sets up an interesting phenomenon. Let's pick somebody to be a liar. It doesn't matter because remember, out of this whole bunch, one of them is going to be a liar anyways. And none of these people are distinct with one another. They're all just smiley faces. So if we pick one person to be a liar, then we can look at how a case would play out. So let's say this guy's a liar. Then that means if we want to maximize the number of liars sitting next, we have to say that one of them's a liar and one of them's a truth teller. So let's say this guy's the truth teller. That tells us that this guy's the liar. Now, this guy's also a liar, as we've established, because this guy sits next to one truth teller and one liar. And we've already established that this is the truth teller just by saying. If this guy's the liar, then we can't force him to sit next to another liar, because then he would be telling the truth and he would no longer be a liar. So then we have to assume that this guy is also a truth teller. Once again, we can start with this guy. If this guy's a liar, then he's sitting next to another liar. And we just keep on grouping people in pairs of two like this, giving one distance between them. But this is where we get an awkward phenomenon, okay? We have three people sitting next to each other. Now, this is where we revert back to the first case. We want to maximize the number of liars in this case. So obviously we want this guy to be a liar. So if we have him lying that both his neighbors are liars, when in reality they're both truth tellers, he's still lying, so he can still be a liar. So we can pick this guy as our final liar. And then we see, Everyone who you circled are liars, and everyone uncircled is truth tellers. Now we can see if the truth tellers are telling the truth in this scenario. The truth tellers would also be saying both my neighbors are liars. And if you check each truth teller, yes, each truth teller is surrounded by two liars. So as you can see, the case works out perfectly. We found out the maximum number of liars. And if we count them all up, we'll find out that this equates to a total of 9 liars. Now this problem is kind of confusing to first go through. But basically what we did is we checked out the two conditions of how the liars could lie. Once we established that, we started out with the generic case, and then we saw how it patterned throughout the entire thing. And then as soon as we did that and we circled out all our results, we just got the answer. This problem is tricky because at first you don't know how to attack it because it's just really unusual. Like the competition is Math Kangaroo, but there's no math whatsoever here. In this case, we literally just did detective work. So with these kinds of problems, here's how you could attack it. You have to set up what you already know, make some deductions from there, and then attack a generic case. That's what we did, and by doing that, we were able to obtain the right answer. So if you see any other problems on Math Kangaroo that does not conform to normal math standards, just write down everything you know and make deductions off that. If you want to go one step further past those deductions, start applying it to generic cases inside the problem. And using this strategy, you should be able to solve most problems on Math Kangaroo.